Today we're going to continue with Java and then dovetail right into the next topic, which is still going to be Java, of course, but we're going to focus more on object-oriented programming. And we're going to start by designing a class and then working with that class. The last thing that we have to take care of Java basics, though, is searching and sorting. And to do that, we're just going to use simple built-in types. We're going to use integers and strings and things like that, things that have a natural ordering. So remember, if you do have any questions, we are online. If you have, you can post to Piazza or you can post to the YouTube chat and we'll see it, okay? So let me come over here. But before we do that, let me remind you of the homework one, assignment one. No collaboration on that is due this Friday by midnight. And at this point, you know, you should have a good start on it at least. Over the next couple, since Monday to tomorrow, if you're keeping track with our Gantt chart here, you should be somewhere, you know, in the, right here, here's today. You should be in the middle of debugging and refactoring and cleaning up your program, giving you that nice bit of pad of 2 days where if something goes horribly wrong, right, then you have enough time to complete it. Otherwise, you know, you can say, all right, well, I got it done early, great, now I can go and work on something else. That padding there is to submit it and test it with the grader. If there's anything, for example, you didn't put it in the correct package, it gives you at least 48 hours to talk to an LA, to post to Piazza, to get that resolved, all right? So if you're following along, you should be in the middle of debugging and refactoring, okay? All right, let me go ahead and get rid of that. So searching and sorting, first of all, we need something to search and sort. So you can search and sort regular old arrays. You can search and sort collections, and so that's what we're going to start with. So list, let's go ahead and create a list here of integers, right? List is equal to a, I can go ahead and actually use arrays.asList to quickly build a list here. I don't know, 8, 3, 9, 2, 1, 0, 4, 7. There we go. So is that sorted? No. Is it ordered? Yes, because it's a list. There is a first element, there is a second element, there is a third element. 8 happens to be the first element, 7 happens to be the last element. So it's ordered in that there is an ordinal system on this, but it is certainly not sorted, okay? So what should I do to sort this? I could write, you know, a function to do this. I could write a selection sort algorithm. I could write an insertion sort algorithm. I could do whatever I want with it. Don't do that, though. You don't generally roll your own sorting algorithms. Instead, you use what's built in to the language or to the library or whatever. And for us, that's going to be in the collections library. Collections, right? Dot. And there is a sort method, right? If you want to sort something that has a natural ordering, in this case, integers, then you can go ahead and do it, right? Let me go ahead and print it out before and after we've done this. So system.out.println list, and then after we've done this, right? And let's go ahead and run it and see that it is in fact sorted. It's sorted in ascending order, or more to the point, non-decreasing order. Because if I had 2 7s here and I sorted it, right, then that 7 and 7, you know, what is that? All right. Which one is was the original first one? Which one is the original second one? It doesn't really matter. Also, this is not really increasing because 7, 7, you didn't increase at all. So technically, all right, you say that this is non-decreasing order. You can call it increasing if you want, okay? So could I do the same thing, say, with a set? No, why? A set is not orderable, right? There's no first element, there's no second element, there's no third element. It's an unordered collection. Could I do this with a map? Maybe, but remember, a map has keys that map to values. Are you sorting the keys, or are you sorting the values, or are you sorting both, right? Those kind of questions, you know, I don't know, right? It is possible to sort by one or the other, but you'd have to dump this key list to a list, this key set to a list, and then sort it, and then you could iterate over it in order of the keys. You could take the values and dump them to another collection, a list, sort it, and then iterate through the values, right? But the map itself, it's ill-defined. You can't really sort a map, right? Okay, so we've got this. What if I wanted a different order here? Well, here, let's go with one more example before we answer that question. Let's go with string, and I'll go with names here. And this will be a list of strings. So Chris, Joe, Anita, and Bob. There we go. So if you were to sort these, in fact, let me go put in another Bob here. Bob. There we go. If you were to sort these, what order would you expect it to come out in? Right? In alphabetic order? It's kind of alphabetic order, but numerical order, lexicographic order, right? So which is the first one that will show up here? Anita? And then Anita? Which one? Who knows? They're indistinguishable, right? Would I be able to do that in a set? Would I be able to put 2 7s in a set? Would I be able to put 2 Anitas in a set? No, because remember, in addition to being unordered, a set is a unique collection. So duplicates are rejected, and there wouldn't be 2 Anitas in there. Right? Okay. Let me go ahead and run this. Anita and Anita are indeed first. Then we've got Bob, Chris, Joe, but then Bob at the end. Why did we get it like that? Because it's lexicographic, right? All caps come before all lowercase. So if we wanted a different ordering, either we wanted to order these in decreasing order, or if we wanted to order these strings but ignoring the case because I want those 2 Bobs together, right? Then we need a different approach, right? And that different approach is going to be, yeah, let me go ahead and get rid of this and get rid of this. Actually, sorry, get rid of the sorting. No, I'll leave it right as it is right now. So let's go ahead and, as our first attempt, we'll create something to sort integers in decreasing order. Right? Now, if you were to do this in C, what would that thing be, that something be? A comparator function, exactly. A function that takes 2 integers or 2 things and looks at them, A and B. Are they in order? A comes before B. It returns something negative. If they're out of order, B comes after A. It returns something positive. If they're equal, then it returns 0. Right? That's the general contract of a comparator. Right? So let's just go ahead and review that really quick. So in Java, you use the built-in sorting method, collections, collections.sort. Right. To get a custom ordering, you need a comparator. And in this case, I'm highlighting it as code because that's what it is in Java. It is a full class. It's actually an interface, but we won't get into that distinction just yet. Right? I'm going to show you how to build a comparator here. But what's the general contract? The general contract is that it takes, I'll put this in a separate line, it takes 2 objects, say A and B. Right? It returns, and I'm emphasizing this here, something negative. If A conceptually comes before B, it returns something positive if they're out of order, that is A comes after B. It returns 0 if A is equal to B, conceptually here, right? Now, these are not necessarily numbers. They could be strings. As we'll see here very shortly, they could be other user-defined objects like you worked with last week in your lab. Children, right? We're going to be using a student object here that I just created, okay? But it takes these 2 things and says, are they in order, are they out of order, or are they equal? And the easiest way that you can remember that ordering is remember the number line. Negatives, 0, positive, right? Are they in order, are they out of order, or are they 0, right? They're both right on that y-axis, okay? So let's go ahead and go over here and create our first comparator. It is a comparator. What is it a comparator for? Well, it's for this list. And this list is for integers. So you parameterize it just like you do for the lists. Now, can you sort a list of integers with a comparator that is intended for strings? No, right? Just like you can't take a list that is intended for integers and expect to insert a string, right? That it would reject that. List.add hello. That will be a compiler error, right? It's not going to let you do that because that is not an integer. It's not going to let you use this comparator for integers for something else. And I'll show you that after we've constructed it here. So this is a comparator for integers. What should I call this thing? CMP int, right? Comparators for integers, descending, right? Yeah, there we go. Or desc, right, is common. Descending, right? I'm going to create a new comparator, again, for integers. And I'm also going to define it right here, right? And we'll come back to this here in a second. Right? But I'm going to hover over this, and I'm going to add an unimplemented method. This is how it does that logic that we just talked about. There is a compare method that returns an integer. That integer is going to be something negative, positive, or 0, depending on the relative ordering of these two elements that you've taken into this function. And I'm going to rename them A and B. Okay? What types are they? Well, they're integers. Why? Because this is a comparator for integers. If you took a comparator for strings, or said that it was a comparator for integers, but then you took a string in an integer, that doesn't make any sense. All of these things have to match. Now, you'll remember this if you're coming from a C background, that if they don't match, the compiler doesn't care. It'll just end up with a segmentation fault or undefined behavior or weird orderings, right? If you gave it a comparator function for integers and you were trying to sort, say, transactions, you're going to get unexpected results. Here, however, Java says, no way am I even going to compile this garbage. Right? Okay. So I've got a compare function. In this compare function, that's where I put the logic. Right? So if A is less than B, then I'll return something negative. What's the something negative that I could return that's easiest? -1, right? Don't get fancy. -42, what? Right? Again, you can't read anything, generally, you can't read anything into the magnitude of the negative value or the magnitude of the positive value. I could be, weird and wild and return 42 for everything instead, right? You can't read anything into that magnitude, so we're just going to keep it simple and return -1. Else if A is greater than B, then return something positive. You can write it as +1. Don't. Weird, right? Else, what's the only other possibility here? A has the same value as B, so we do what? We return 0. Right? And now it should compile, and it should be happy about this. Let's see it in action, and then we'll come back and talk a little bit about the syntax here. So if you want to sort a list, if you don't give it a comparator, it defaults to that what's called natural ordering. It's going to sort it in non-decreasing order, in increasing order. But if you change this and say that, oh no, don't use the natural ordering, use the ordering that is defined by this comparator that I just made, then it'll use the logic in that comparator instead. So let's go ahead and take a look at this. Oops. Well, it certainly did use the logic that I did. What did I want? I wanted descending, though. So let's take 5 and 10. If it's in descending order, are they in order or out of order? Or here, 2 and 5, since I don't have that many fingers. So 2, 5, is that in order? Nope, that's out of order. So what should I have done here? Flip these. Okay. Now, when I run this, you'll see that it is in decreasing order or non-increasing order, technically. Okay? All you need to do is flip those two around and get the other ordering. Right? You can reverse the ordering. Now, let's talk about the syntax here. Again, I'm creating this comparator. It is a part of the, what class is it called? It's Java util.comparator. You do need to import it because it's not part of the standard java.lang library. You provide a parameterization for that particular type that you are comparing. Call it whatever you want, right? In this case, I've called it CMP int descending. It is a local variable, so you should follow the same local variable naming conventions, lower camel casing like I did here. If you want to, you can go ahead and fill this out in full. Comparator for int descending if you want to, but CMP is good enough, right? And then I'm creating a new comparator. I do have to parameterize this, but I don't have to repeat integer over here. It will infer that. And then what I'm doing is I'm creating a new one. Just like I created a new list down here, or I didn't do it here, but you could create a new list for integers. Integer foo is equal to new array list. Right? We've seen this syntax before. Right? Sorry. This is invoking what's called a constructor that we'll get to by the end of the day here maybe. But in any case, it is creating a new list. This is creating a new comparator. Now, technically speaking, a comparator is actually just an interface. But what I'm doing here is called an anonymous inline class. Right? Don't worry about that distinction yet because we're not into object-oriented programming. Just know that what I'm doing here is I'm creating a new one, and I am defining it in the same line. Right? I'm creating a new one, and then I'm providing this opening bracket, closing curly bracket, followed by a semicolon. Why? For the same reason I provide a semicolon right here. I'm creating a new one, and I'm defining it at the same time, end. Right? That's my command. Okay? I'll go ahead and get rid of this. But otherwise, if you hover over it, it'll produce this public int compare, and then it takes two elements, A, B. I usually just call them A and B. If you auto-generate this code, it'll call them like usually O1 and O2. You can go ahead and rename them to whatever you want. Then inside of this, you provide your logic that encapsulates this idea. Given A and B, whatever they are, if they're integers, if they're strings, if they're whatever, then you provide that logic for ordering them. Then you give it to your sort method, and it takes care of the rest. Right? It knows how to sort. It just doesn't know how to order. What are these two things? I don't know. Whatever they are, I can swap them. You tell me what they are. They're students, or they're strings, or they're integers. How do you order students? Oh, by last name. Oh, okay. Oh, no, I want to order students by GPA. Oh, okay. That's a different comparator. Right? What would it look like for strings? Comparator for strings. Right? CMP, should I call it int? str string, right? And in this case, I want to ignore the case. Ignore case, right? Is equal to new comparator. Right? Oops, sorry. There we go. And then that way. I need to spell it correctly too. There we go. There we go. Comparator, right? I doubt that if you look up Webster, whether or not this is a real word or not, comparison, comparing, right? All that kind of stuff. A comparator, we just, a nounized version of a verb, right? Usually you go the other way around. You take a noun and then you make it into a verb, like a gerund, right? We're going the opposite direction, right? I don't know if there's a word for that or not. Is there? Language folks out there? No? All right. All right, so I auto-generated this code, and I'll simply call them, you could call it S1, S2, or in this case, again, I'm just going to go ahead and go with A and B here. All right, so how do I make a statement of the form, if A is less than B, ignoring case, then return something negative? How do I do something like that in Java here? Well, strings are already comparable. Right? If I go a.compare2, that other string, that has the exact same contract. It will return something negative, positive, or 0, depending on the relative ordering of A and B. Right? In fact, that's how this is working down here. If you don't give it a comparator, it defaults to this compare2 method. Right? Now, hopefully you saw, if this is less than 0, right, then I'll return -1. Hopefully you saw when I did a code complete here, though, that there was another option, .compare2. What's that other option? Squint really hard. compare to ignoring case. Right? So if that returns something negative, that means that A comes before B, ignoring that case. Okay? Else if A dot compare to B returns something positive, then I need to return something positive. Else return 0. All right? Let's see it in action, and then we'll try to improve it here in a second. So it should be, as before, it was Anita, Bob, Chris, Joe. Those two Bobs now should be together. And they are, because it's ignoring the case. Now let's take a look at that logic again. If this thing over here returns something negative, return -1. If this thing over here, ignoring case, sorry. That's what you were probably, case, there we go. If this thing returns something positive, then return +1. Otherwise, that thing must have returned something negative, returned something, 0, and so we'll return 0. Is there a way that I could parse this down from 1, 2, 3, 4, 5, 6, 7 lines of code to a one-liner? What? Well, whatever A dot compare to ignores case returns, just return that and be done with it. And it'll work exactly the same as before. Those two Bobs are together. Okay? There's got to be an easier way of doing this stuff. Right? And there is, and I'll show you here in a second. Any questions about sorting the built-in stuff? Integers, doubles. Everything is automatically comparable in a natural order. If I've got doubles, of course, it will order it naturally in ascending order. Strings, Booleans, false comes before true, but then you'll just have a bunch of false, 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 and then a bunch of true, 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 true. I don't know why you'd ever want to sort Booleans, right? But you can if you want to. There is a natural ordering there. So any questions about the built-in stuff? Yeah, go ahead. Oh, sort of list of characters. Good question. So list of character, right? So chars. That's a bad name, but for demonstration purposes, it's okay. Arrays dot as list. I don't know. A, Z, B, Q, Y. There we go. There's arrays dot as list. They are naturally comparable, so you could go ahead and just sort them normally. Collections dot sort chars. Right. Oops. There we go. And this will sort it in lexicographic order, I believe. A, B, Q, Y, Z. Right. And it'll also sort it in lexicographic order again, so that the capitals come later. So if I've got A and B, and if I even have other things like exclamation point, right, then it'll simply give me the ASCII text character table ordering. Right? If you wanted a different way, if you wanted a comparator for characters, CMP chars, in the opposite direction, I guess. Right? Character, right? Character, character. So how do we compare characters? A dot compare to, right? B. And if you want it in reversed order, what would you do? Simply just take a negation of it, right? Positive becomes negative, negative becomes positive. And if I use this now in descending order, then I get the exact opposite order. If you wanted to ignore case, I would convert both of them to uppercase and then make the comparison, or convert both of them to lowercase and then make the comparison. But that's a variety of ways that you can do that. Does that answer it? Okay. All right. Then let's look at how we can do this with a user-defined type. In this case, I've built a student class. This is very, very similar to what you used in your Lab 2. We built that class for you, though. It was children and their ages, their names and their ages. In this case, however, I've defined a student to have a first name, a last name, which both of those are strings, an NUID, because of course they're matriculating here in the state, and then a GPA, which is a double, okay? Don't worry about the rest of this stuff here yet. This is a constructor. This is how you can create students. Then we've got a bunch of getters. If you want to get that student's first name, get their last name, get their GPA, you can use them just like you used in Lab 2. Right? So let's come over here to the demo, and let's create some students here. Right? So list of student, roster, say, equals new, actually no, arrays dot as list. There we go. And what I'll do is I'll create a bunch of students inside of this thing. So new student, and I have to provide everything. I think I have to provide the order is first name, last name, NUID, GPA. So let's go ahead and go with a couple of students here. Me first. 1, 2, 3, 4. I'll just make up the NUIDs. I'll give myself a 3.5. And a couple of other people here. Joe, Anita, doing better than me, doing worse than me, and then some people with other last names here. Anderson, Zoe, Anita Zoe, and different first names here too. Jay, and just making up data here. 4, 5, 6, 7. 2, 2, 2, 2, 0, there we go. Just mashing the keyboard here. 1, and then, I don't know, 2.5. There we go. Just for variety. Okay? So, how would you go about ordering these students? Sorting these students? Well, who should come first? Is my question. Say what? Me? By what criteria? So you want to go by first name? First name then would be Anita, right? Do we usually sort by first names? No. We sort usually by last names, and then if you've got a bunch of people with the same last name, what do? Then you go to the first name. So let's go ahead and try doing that. First of all, if I use collections.sort, right, then I get roster here. It's not going to let me do that. Why? This is a user-defined type, right? Java doesn't know. Java knows about the student because you defined it over here, but it doesn't know. Well, how do you want to do this? Do you want to go last name, first name? Do you want to go last name, first name in descending order or ascending order? Do you want to go with a GPA in ascending or descending order? Do you want to go with the NUID, descending or ascending order? Or do you want to go for some combination of all 4 of those things? Right? We, without telling it, because it's a user-defined type, it has no idea how you want to order this. So consequently, we have to come up with a comparator for students before we do something like this. So I'll go ahead and call this CMP student, and instead of characters, it'll be students, student, and student. There we go. Oops. We still have to implement it, of course. But now if I use this in a call to sort, the compiler is at least happy about that. Right? And system.out.println roster. One thing I forgot to do over here, ignore this for now. Source, generate toString, and so that we can at least see them, right? So let's go ahead and print it out before and after. Right? But before we do that, we actually have to implement the logic here. So given A and B, what do I look at first? And by the way, this is going to be, like we said, by name, by last name, then by first name, breaking ties. So what should I look for? A dot get last name, and I want to compare to B dot get last name. Well, guess what? Those are strings. And do we know how to order strings? Yep, either by using this comparator if you want to go and ignore case, or just simply compare them. Remember what we did in there was we used a.compare2. So instead of returning that value immediately, let me capture that value. Int R for result, is equal to a.getLastName dot compare to b.getLastName. And that will be one of three things. It will be something negative, something positive, or 0 depending on their last name. So if it's something negative or something positive, we're done, right? Burke comes before, or Anderson comes before Burke. Burke comes before Zoe, right? So if it's not, only if it's 0 do we have to look at the first name, right? If R is 0, then we must break the same last name tie using the first name, ... How do we do that? A dot get first name dot compare to B dot get last name. Careful, right? Should you be comparing apples to apples and oranges to oranges, or apples to oranges? Right? Make sure that everything matches. And you can get yourself into a lot of trouble if you're doing a lot of copy paste. I'll show you an even better way here in a moment. All right. Otherwise, I'll return R, because if you are already if you have already determined that this student should come before this student because of last name first, or the last name itself, then there's no need to look at the first name at all. Right? So let's see how this works out. CMP student by name. Unfortunately, it's not going to be very nice to look at. There it is beforehand, and there it is after. Anderson, then Anita Burke, and then me, Chris Burke, then Joe Burke, then we get Zoe last. Okay? What if I wanted the reverse? I would return the negation of this and the negation of that, right? Simple enough. In fact, it can get even simpler. What if you wanted to do this by NUID? Or what if you wanted to do this by GPA? Let's go ahead and write out a full comparator for GPA by GPA. And instead of looking at the last name, first name, what I'm going to do is a.getGPA.compare to b.getGPA. And I'll simply just return that. Except there's a problem here. It's not going to let me do that. So let's take a look at the function that gives me the GPA over here in student. GetGPA returns this object's GPA. Well, what kind is that? It's a regular small d double. Small d doubles do not have a function, any methods that you can use like compare to. Right? So you do have to use the full logic that we used up here. If a is less than b, then you return something negative. If, in fact, I'll write it out here. If a.getGPA is less than b.getGPA, are they in order or out of order? Do we want to go 4.0 down to 0, or do we want to go 0 down to 4.0? Which should be at top? 4.0? Okay. So that means that we're going to be going descending order. If A has a 2 and B has a 4, are they in order or out of order? They're out of order, so we should return something positive. Else if, exact same logic here as before, but if it's greater than, then I'll return something negative, else return 0. It's generally best practice to leave the tie at the end in this case, especially in this case, because you don't want to go using equals equals, because 4.0 is probably equal to 3.999999, right? Depending on, there are lots of floating point issues to get into, and so to avoid all those issues, simply just leave this as your third option. Okay. Let's go ahead and sort these by GPA now instead of by name, and run this. There we go. Let's see. Anita goes first because she's got a 3.7. Then me 3.5, 3.25, 3.15, and then 2.5 at the end. Okay. There are better ways of printing this stuff out, but we'll get to that later. Okay. So lots of code here. In fact, how many lines of code is this? A dozen? Here's an even easier way. If I want that comparator in fact, let me go ahead and I'm going to reuse this. So let's go ahead and comment this out. I'll leave it there so that you have it in the notes. But what I'm going to do is I'm going to use what's called kind of like this is kind of like what's called a builder pattern. Comparator dot comparing. Right. So I don't think that I go new here. No, I don't go new here at all. So the comparator class itself has this factory function that allows you to build a comparator. Right? This comparator, you can say, I want to do this by comparing the GPA of the student. So here's some new syntax that you have not seen that was introduced in later versions of Java. It's called a method reference operator. I forget. It comes from C++ if you're familiar with that. Get GPA. There we go. There. A one-liner that replaces all of this code up here. Now, this is still in the natural ordering, right? So when we print this out, we're actually going to get the 2.5 up here and then the 375 down here. So let me go ahead and show you that really quick. 2.5 is first now, and 375 is last, right? That's okay, because you can always reverse it, right? And get the opposite direction. So let's walk through this character by character. This is the class. It's kind of like math.square-root. I'm asking comparator, build me a new comparator. Okay, I'll do that. How do you want to compare it? I want to compare students using this method. So you generate the code that automatically does what we did up here by calling that method and making those two comparisons. Right? And then it says, okay, that's good. Anything else? Yes, I also want it reversed. Right? You can use this to break ties. So for example, you can have a really elaborate comparator. CMP student, just student here. Comparator.comparing student, let's say last name, get last name. Right. Then comparing student first name, or get first name, I think it is, first name. There we go. Then comparing student GPA. And also, I want it all reversed. Right? Now imagine if you had to write this logic yourself. 3 different criteria, right? And then also, reverse it. You'd have to have an if. Okay, now break ties here. If, else. Okay, now break the 3rd tie here. If, else. If there's a 4th tie, a 5th tie, a 6th tie, right? If you have a very, very complex kind of object here, a very complex class, that nested logic can get very, very difficult. But using this pattern, right, this kind of builder pattern, and it does the work for you. Right? Yeah. I think that's a good question. Let's RTM. Hover over it. Come on, hover over it. I think it's the entire thing, not just the last thing. But you could, if I'm wrong, reversed dot. Well, yep, reverse it. So if you wanted to reverse all of those, dot reverse. So I might be wrong, actually, if it's allowing you to do something like this. Each one individually has to be reversed if you want completely different orderings on all of them. Right? But without those, what would this do? This would go last name, because that's what we started out with, in descending order. Then, for all the people that have the same last name, Burke, 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 then we go to the first name in descending lexicographic order. Then comparing, then GPA, but in increasing order. But then here we end up reversing that last one. You can play around with it and find out for yourself. But again, this colon, that's syntax that was introduced later in Java. It is the class name, and the class name here is student. And then it's a reference to one of these methods, right? And that you use a colon referencing that method. You don't actually call that method. If you put a parentheses here, you would actually be invoking that method, and that's not what you want. This is very similar to C, where you have function pointers, right? This is basically kind of like a function pointer. It's a reference to that particular function in that particular class. Right? All right, any questions on searching and sorting? Well, we didn't do any searching, did we? So let me go ahead and take all of this and make sure that you've got it in the notes. And then let's talk about searching. What's the only way to search? I mean, there are lots of ways to search, but what's by far the best way to search? If it's already sorted, you can do what? Let me get rid of all of this. And we'll use a natural ordering here, okay? So if this is a sorted list of integers, if we looked in the middle and we didn't find what we were looking for, say that we wanted to search for some, I don't know, search for int key is equal to, I don't know, 5. Right? Is that going to be a successful search? Nope, because 5 ain't in there. Right? How could we go ahead and search this in an efficient manner? You could look at the first one, that isn't it. You could look at the second one, that isn't it. Look at the third one, that isn't it. And get all the way to the end and find that 5 is not in there. What's a better way of doing it if it's already sorted, though? Binary search. Collections dot binary search it, right? And I went too fast on that. Let's go ahead and go back and look at the arguments here. Binary search. There are two versions. One of them takes, both of them take a list and a key. And then the second one optionally takes a comparator. Because if you custom sort it, then you also need to custom search it with the comparator that you sorted it with. But let's go ahead and let's go ahead and just use the natural ordering here. I want to search out the list for that given key. Right? It searches it. Oh, I didn't find it. How do we know that it didn't find it? Again, let's RTM. It returns an int. Well, what is that return value? The method, let's see, here's the return value. And unfortunately, you have to squint your eyes. I'll read it to you. The index, it returns the index of the search key if it finds it, if it is contained in the list. Otherwise, it returns something negative. Why does it return something negative? That can't possibly be a valid index, right? It can't return 0 because 0 would say that, oh, I found it at the first element because it's 0 indexed. Instead, it returns something negative saying, nope, that doesn't exist. But you can actually read into it a little bit more. It actually gives you more information about it. That if it were to exist, and you negated and subtracted 1 from the number I give you back, that's where it should be. That would be its insertion point if you wanted to insert it, to keep that ordering. Don't worry about that for now, though. So let's go ahead and use this. Int index is equal to collections.binary search, and let's report it. System.out.println found. Actually, let's go printf found %d at index %d and the line. So we found the key at that given index. So are we going to find this or not? Nope, because it's going to return something negative. Right? So I'm saying found at, right? If you want to quote something, by the way, inside of a string, how do you do it? You just need to escape the double quotes there. So I found it at index -7. In other words, it didn't exist because 5 is not in here. Right? What if I searched for something else? What if I searched for 4? And remember that it is sorted. So 0, 1, 2, 3, 4. It should be at index 4. Right? Yep, we found it. What about 7? That's going to be at index 5 and 6. Which one does it return? Roll those dice. Right? I have no idea. In this case, it found out 6. It doesn't have a guarantee that it's going to find the first one or the last one, or if there are 10 sevens, right? 7, 7, 7, 7, right? And we sort this, right? It's just going to find a 7, right? Looks like it's always finding this one because when it's sorted, that's in the middle. It gets lucky and it immediately finds it. So if you need a review of binary search, make sure that you're going back to the Computer Science 1 resources and learning about binary search. Again, all it does is, here is a sorted collection, right? All you need to do is go to the middle and say, oh, is this what I'm looking for? No, the thing I'm looking for is less. And so you recurse or you look at this half of the list. Or if the thing that you're looking for is greater, you look at this half of the list. Either way, you've cut the input in half each time. And that's why it's going to be extremely efficient to do something like this. If you have a list of students, fine. All you have to do is sort it by that collection and then search it by that same comparator that you used to sort it. Otherwise, it's pretty straightforward. Now, there is a linear search as well. For example, before you even sort this, you can search for it. List.indexof is the linear search. Index of, say, 7. Actually, I'll move the key up here. There we go. And I'll use the key. There we go. Int index. And I won't redeclare it down here, but I will report it up here. Right. So this one will work. It'll find the first one, right? It finds it at index 4 because before you sort it, 0, 1, 2, 3, 4, the first 7 that it found was at index 4. And so it does. If you don't want to sort it, fine. You can use index of. But that's just a regular old linear search. It starts at the front and it works all the way to the end until it finds what it's looking for, or it gets to the end and that's an unsuccessful search. So, for example, if you search for 42, which is definitely not in this collection, sorted or otherwise, then it's going to return -1. Right? The only flag value that makes sense. Questions on searching, sorting? Okay, so again, this is a basic linear search. And you have also basic linear searches in sets and maps as well. It's just not index of, it's going to be contains, right? So, for example, if there's a set of integers, integer set of nums, is equal to new hash set. And what I'm going to do is I'm just going to make a copy of this list. And then I'll say Boolean exists equals set of nums, nums dot index of. Can there be an index of with a set? Nope, because it is unordered. There is no first element. There is no last element. There is no middle element. So I can't use index of. Instead, I need to use contains, right? And does it contain the key that I want? System.out.println exists. So does it contain 42? False. No, it does not. Does it contain 7? True, it does. Right? So you can do a linear search, and it's not going to go in order because there is no order, but it will exhaustively search the entire set. Okay? So this is a basic linear search on sets, and then binary search. Binary search on lists. Can you do a binary search on sets? Nope. Again, there's no middle element either. Okay? All right. Questions so far? Searching. And as always, these notes are updated at the end of the day. They're all on GitHub. All right. Okay, good point. Pointed out on a line here that according to the documents, collections.sort is guaranteed to be stable. So what was sorting stability? Remember when we've got duplicates, 2 Anitas, right? There's no distinction between those two things. But if they were in relative order to begin with, this Anita and this Anita, right? Subscriptum, A and B. Then you went to sort it, stable sort would never put these two out of their original order. It would still have the first Anita and the second Anita, right? And collections.sort is guaranteed to give you that property, right? So if you're ever concerned about sorting stability, then collections.sort is guaranteed to give you that. Right? All right. Okay. Somebody also says that it's anthromeria. I'm not sure what that's referring to, but anyway, let's go back. All right. So questions so far? That's basics of Java. You have more than enough at this point to get homework 1 done, right? Let's review what your, and I've closed the Gantt chart so far, but what are the three exercises that you have to go through? One of them is basic input-output. It's the win percentage expectation, right? So there you're using variables, you're using basic input and output, command line arguments, you're using the math library, right? Not even any loops are required for that one. With the entropy, you are doing file I/O, right? And we've covered that. Maybe you'll want to use a map there, hint, to count up the number of elements. You're also using the math library there, and also, of course, you're using loops. So file I/O, loops, math library. The last one, which is a game development report, there you could probably get by on using just a bunch of strings, numbers, and maps as well, right? But another thing that you could do, and we're not expecting you to do, is to design a class that represents a game and or a platform and or a publisher. You don't have to do that though. Right? But that gets us into object-oriented design and designing classes. So let me go ahead and close these notes and open up a different set of notes. Right down. Go. Okay. So creating classes and designing classes. We've already used some classes before. You used the child class in your lab too. You'll maybe teams or something like that as well. But in any case, I created a student class here as well, right? This is a class that represents a student. What we're going to do is we're going to go back to our isotope demonstration, and we're going to make this into a little bit more object-oriented programming kind of style, right? To do that, we need something to represent an isotope. And in Java, that means that you're designing a class to do this for you. So as a review, Java is a class-based, object-oriented programming language. Right? That just means that everything in Java is a class or belongs to a class. Right? It's unlike C, where C you've got everything just lives in the global space or in modules or something like that. Like a function, you can have a function, the square root function doesn't live in it exists in the math library, but there's no math class that it belongs to, right? A class in Java, in fact, I'll go ahead and codize that. Oh, it's kind of small. Zoom in here. Big enough in the back? Okay, give myself some more room here. A class in Java allows you to model a real-world object or idea or entity, right? It allows you to group multiple pieces of data together into one logical unit. Where have we seen that before? Those coming from a C background. If you've got, say, this transaction, and a transaction has an original account balance, the amount of the transaction, and then the destination of the account. If you're transferring from one account to another account, the account number to an account number, you're transferring $50. Here's the balance before, here's the balance after. All those things, those 6 or 7 different pieces of data, you can encapsulate it into one thing and see that thing is called a what? A structure, right? In Java, we use classes to bring those things together, right? And this is known as encapsulation, right? But it goes a little bit further in Java because it also allows you to encapsulate methods within the class that act on or operate on that class's data, right? And we'll see that here in a moment. That's the extra thing. In C, we have weak encapsulation, where you can group things together into one logical unit. In Java, we have 2 more things. One of them is actual functionality, right? i.e. functionality. Right? It allows you to group functionality together with the data that it functions on, i.e. it allows you to group functionality together with the data that it functions on, operates on. There's a third aspect to encapsulation. Java classes also allow you to protect its data from outside of the class. Right? You don't have these two things in C. In C, you just have structures where you can take a bunch of things and group them together into one logical unit. A student would look like a first name, last name, NUID, and GPA. 4 pieces of data grouped together to model one particular thing. But in Java, you have additional things. You can protect that data from the outside world. And now, this is not a security protection. This is a design perspective. We'll show that to you in a second here. So it's not like you're securing it, you're encrypting it, or something like that. You're just, from a design perspective, nobody can access this data without your permission, right? And that's where getters and setters come in. But it also allows you to group functionality on that data. Now, with our student class here, there's not much functionality, right? You can get their first name, you can get their last name, you can get their GPA, whatever. You can pull stuff out of the class. There's not much non-trivial functionality to this thing at all. But now let's think about an isotope. What behavior, what functionality does an isotope have? A radioactive isotope. It has decay, right? So it has, after a certain amount of time, there's radioactive decay, it is decayed, and there's less of it now. So if I want to decay this isotope, and it originally had 10 kilograms, and I decay it for 30 years, now it only has, say, 5 kilograms. Right? That sounds like functionality that acts on the mass. Right? So maybe we should group that functionality inside the class when we redesign this. We're not there yet, though. Okay? So what we're going to do as a first demonstration, let's design a class that models a radioactive isotope. Okay? And let's go through this process. I renamed this isotope demo so that I could create a brand new class called, come on, right click, new class isotope. Right? So the first thing to note here is the naming convention. The same naming convention that we mentioned before. If you create a class, what naming convention do you use? Upper camel casing. So in this case, it's a capital I. Over here, isotope demo, it was a capital I and a capital D. Right? Student, it was a capital S. That's the convention. Okay? So now don't worry about everything that we did in this demonstration, this decay and this stuff like that. Just worry about what is an isotope. Right? Let's take care of that first part, where we group multiple pieces of data together into one logical unit. Tell me about an isotope. What does an isotope have? All I had to do for a student was think, well, what does a student have? Well, a student has a first name and a last name. I didn't just think that a student had a name, right? That would be kind of weird. Your name was all scrunched together. Is it first name, then space, then last name? Is it last name, comma, space, first name, right? Too many. That's too brittle. There are too many potential failure points there. But by separating it out into first name and last name, we're good. You might also want, surname, preferred name. You might want middle name. You might want suffix and prefix, right? Junior, Mr., Mrs., whatever, right? You might want to support all that stuff, and that'd be great. I just have to create more and more variables to do so. All I wanted to do here was first name, last name, NUID, and GPA for the purposes of demonstration. But now let's think about an isotope. What is an isotope? What did we do before? What did an isotope have? We read it from the command line, right? So here's a tip. Semantics dictate design, right? If you say, a transaction has an origin account number, a destination account number, a balance, and an amount of their transaction, guess what? We just told you exactly what should be in that class, right? So what should be in that class? Atomic number, name, symbol, half-life, maybe mass, I'm not sure. Let's go over here to the isotope and put those things in there. Right? Now, obviously, I'm not reading command line arguments here yet. Right? So I have an atomic number, a name, a symbol, a half-life, and an initial mass, or maybe just mass. Right. I'll put a question mark there. In fact, be a good programmer here and make sure that I put this in a to-do. Should we have this? Question mark? I don't know. Okay. That looks like a good isotope to me, right? Every isotope will have an atomic number. It doesn't change, right? If I've got an isotope of strontium-90, is it magically going to, well, I mean, when it decays, it becomes something else, but that's not magic. But is that particular model, is it going to change? No. Name, its name doesn't change. Symbol, half-life, but mass, does that change? Yeah. So you could have an isotope sample over here of strontium-90 that was 5 kilograms, and over here you could have a sample that was, say, 10 kilograms, right? Those would be two instances with different masses, but they would share the same atomic number, name, symbol, and half-life. Those things don't change, right? We call that non-fungible, all right? It doesn't matter if you, for example, stocks, 50 stocks that is fungible. This is fungible, excuse me. I always mix up the two. Something is fungible if it can be exchanged for an equal amount of the same thing. So for example, if I had 50 Google stock, right, 50 shares of Google stock, that's fungible. I can trade that for 50 shares of Google stock, and I didn't gain anything, I didn't lose anything. It's not like I owned like that square footage of Google stock over there versus somebody owning that square footage of Google over there, right? It's a fungible, right? It can be exchanged. An isotope is fungible because it has the same atomic number, same name, same symbol, right? Might just be different amounts of the actual amount though, right? So thinking like this starts to, grind the gears and starts to think, okay, how do I model this in my code? Because mass can change, but these other three things can't change, okay? So let me go ahead and go back over here to demo, and let me go ahead and create some isotopes. Isotope. What, sample A. There we go. So once you've created a class with a particular name, you can declare a variable. I'm gonna get rid of student. You can create a variable of that type, right? Now this is of type isotope, just like I do, say, int x, right? That's an integer. The type is int, the name is x. The type here is isotope, and its name is sample A, right? Sample B, right? What would happen if I printed these out? Did I say that these were strontium? Did I say that this was plutonium or whatever? Nope. What would happen if I printed these out? Sample A and sample B. Okay, wow, you're not going to let me do that? Fine. I'll do it for you. By default, there's no default value for a local variable. They were uninitialized. So I didn't create them, so it's just going to be null. I don't know what this is, right? Yeah, go ahead.
I think you can add a two-string
You can, and that's where we're going eventually. But even now, you can't invoke that. You can't invoke that because it hasn't been initialized, right? For example, there will be a two-string method there, but it still won't let me do that because sample A hasn't been initialized. Now, if I initialize it, it'll let me do it, but it'll also, now you see that this is yellow. Now it'll warn me, wait a second, that's still that's null. You can't call a method on a null object. And in this case, it'll be different. This won't print out null. This will end up throwing a null pointer exception, right? Because sample A is still null. Right? All right. So we need a way to initialize our variables in a sensible manner. Okay, fine. I will go new isotope. We've seen this syntax before. New list, new set, right? New array list, new hash set, etc. Anytime that you want to initialize as a new object or a new thing, you use the new keyword, okay? Now, when I do this, and I print out sample A and sample B, I will get a different behavior because now they actually exist in memory. But did I set anything? Did I say what name it was or how much mass there is? Nope. So I just get this gobbledygook, right? This is nonsense. Now, this is the default behavior of the toString method that you were talking about. All it's going to do is print out the name, the fully qualified path name. So this is the package, this is the class name, and then this hex code right here is the Java virtual machine memory address. If I were to run this again, it probably likely won't be the same. Oh, okay, it is. It's being loaded up in the same memory location. All right. If I throw a loop in there though, and say C instead, now it should be different because I've changed the code. Yeah, there. Now it's different for all of them. Right? It's loading them up in a different memory location instead. So let's go ahead and get rid of this and get rid of this. So how do I go about setting these things, say, to strong TM90? I can use the dot operator. Do you remember the dot operator from structures? Sample A dot name is equal to strong TM. Is that how you spell it? It's not strong TM, it's strong TM, right? All right, nobody cares about physics. All right. Sample A dot atomic number equals, what is the atomic number of strontium? Help me. Is it 40? 38? Thank you. That sounds right. Sample A dot half-life was something like 28.9 years. Sample A dot mass. Let's say that we start out with 10 kilograms. And what else? Sample A dot, I even have to look over here to find out. Half-life, symbol. That's what we forgot. Symbol is equal to SR. There we go. Now I've got one sample of 10 kilograms of strontium, 90. This should be 90, right? There. It's an isotope. Sample B. There's a use case for the code block selection mode. Sample B. Name, same, but this mass will only be, say, 5 kilograms. Right? So I want another sample, and another sample, and another sample, and another sample. Does it seem like this is a good way of going about doing it? We didn't even do this when we did structures. When we did structures, what did we do? I don't want to have to do this over and over and over again. I want a function to do it for me. Right? In this case, we're going to make that function. Let's come over here to isotope and create what's called a constructor. It's called a constructor. Why? It constructs an instance of a class. So here's the basic syntax. Public isotope, and then you take your parameters right here. So int atomic number, string name, string, I hate typing. There must be a better way. Double half-life and double mass. There we go. So to do, implement this. Now before we do that, how is this different from all the other functions that we've written so far? There's no return type, right? Why is there no return type? Because it's a special function called a constructor. What is it constructing? It's constructing an isotope. Same name here, same name here. Do you need a return type? No. It knows what it's doing. It's constructing an isotope. Over here in student, the constructor had no return type because it was constructing a student, right? So implicitly, there is no return type here because it knows what it's doing, right? It's constructing whatever class you're inside of right now, right? Okay, I've got two atomic numbers here right now. I've got a variable named atomic number up here, and I've got a variable named atomic number down here. I want to take the value that was passed into this constructor and put it into this variable up here. These are referred to as member variables. How do I do that? Atomic number is equal to atomic number. Is that right? Compiler's complaining about it, at least. Compiler's seeing something wrong with it. Let's ask the compiler what's wrong with that. The assignment to a variable atomic number has no effect. In other words, it's telling me I'm doing something like this. Int x is equal to 10, x is equal to 10, x. Would you ever write a piece of code like line 15? Nope, it's saying take whatever is stored in X and put it right back into X. And that's exactly what's happening on line 12, and it's warning me about it, right? There are two variables called atomic number here. Without qualification, I should say, both of these refer to the parameter variable up here. How do I refer to this particular variable, though? Exactly. This dot, right? So emphasis on the this. What is this? Well, this is this isotope. Out here, over here in the demo, and there are compiler errors, we'll talk about that next time. But out here and over in the demo, if I have sample A, sample B, sample C, I have names to give to those samples. Sample A, sample B, sample C. But if I go inside the class, right, do I have a name to refer to any instances? No. So when you were talking to other people, you can call them by name. Hey, Joe, how you doing? Hey, Anita, how are you doing? Right? But what name do you give yourself? Me, myself, I, right? But this is not a person. This is an object. So if we anthropomorphize the object and say, what would an object call itself, right? What word do we use then? This, right? Now some languages do use me, self, and nobody uses myself. Nobody uses I. But there are languages that use those two other terms. They anthropomorphize their objects, and that's a Visual Basic. Any Visual Basic folk out there? Nope. They use the keyword me. Hey, me. Otherwise, other languages do use self, but it's usually referring to the class itself, right? Not to an instance. So this dot atomic number, and type this. I don't know if I'm going to be able to get this done in the next 4 minutes. Let's try. Name this dot symbol. All right, I've already given up. That's okay, because I can get it done in 3 seconds. Source. Generate constructor using fields. Generate. Thank you for typing for me. All right, all done. Well, what is the super? Super is my parent, my super class. We'll get into that when we get into inheritance. This is completely optional. It's just auto-generated. Right? And also it auto-generates nice Java.code. Document this. But you don't have to document it, because a constructor is, in my book, is one of those trivial methods. You know what it's doing, right? Or so you don't need to say, this is my awesome constructor, blah, 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 right? Now, if you just leave it like it is, it's probably good enough. If you want to document it, go ahead. If you want to get rid of the documentation that was generated entirely, that's also okay. Okay? Any other questions? Sorry, again?
How did you get the
Source, generate constructor using fields, and then you can, I only want to do it with this one or that one or that one, right? Or select all of them, and that's what I did, but of course it already exists. Okay. Can't do that a second time. Is that your question? Okay. Source, generate. And by the way, when we do more stuff, you can generate getters and setters. You can generate a toString method, right? All this boilerplate kind of stuff, you can auto-generate it. All right, we'll continue there next time.